In this video, we're going to go over exponents and unit conversions. So the 5 topics on today's menu is going to be positive integer exponents, zero and negative exponents, order of operations, evaluating algebraic expressions, and converting units. So let's go ahead and let's get started with our review of positive integer exponents, which you already have an idea of what this is. So just remember or recall that a to the n means a times a times a, and you will keep doing this for n times. So our example that I'm going to put on the board here is something like 2 to the third power. Well, that means 2 times 2 times 2, and we know we can evaluate that to give us 8. So now the big question becomes, what kind of math can you do with this? What are the operations that coincide with positive integer exponents? So remember, we have, I think 1, 2, 3, 4. Yeah, we have 4 of them here. Actually, there's more, but we're going to review 4 right now. So the first one is called the product rule. Okay, and it's just what it sounds like. Product meaning multiply. So a to the m times a to the n equals a to the m plus n. Now I'll give you an example in black. So here's our example here. We're going to do 3 to the 4th times 3 to the 9th. Well, that's going to be 3 to the 4 plus 9, which is 3 to the 13th. So that's our product rule. The next rule is going to be the quotient rule. Okay, and once again, it's exactly what it sounds like. Quotient rule deals with division. So a to the m divided by a to the n is going to equal a to the m minus n. Now, the only caveat to this is a is not allowed to equal 0. Okay, so an example would be something like y to the 15th divided by y to the 2nd. Well, that would be y to the 15 minus 2, which gives us y to the 13th. Now, the next 2 rules that we're going to go over are nothing more than just the product rule and the quotient rule, but they're like expanded. Okay, so let me show you what I mean here. We have our power rule. All right, now the power rule says this. It says if you have a base raised to an exponent that is raised to another exponent, I should be writing this in red. There we go. Raised to another exponent, we multiply the exponents together. Okay, so a really nice example would be something like 1/3 all raised to the third. Well, if you notice, the 1/3 is raised to the first power, so we're going to get 1 over 3 to the third. Actually, technically, it's 1/3 over 3 to the third, which is 1 over 27. So this still applies if you have fractions or something like that. Okay? Now, the next rule is what we call the general product to a power. Now, your book kind of just shows you it, but it actually has a name. And sorry, my dog is barking in the background. So here's the general product rule. Let's say you have different things that are being multiplied, and they are all exponents of something, and they're raised to another exponent. Well, all you're going to do is you're going to take that outside exponent, and you're going to multiply every single exponent inside of the parentheses by the outside. So I guess a way, if you want to think about this, is you're like distributing the letter P to the letter M and the letter N. Okay? So let's see one of these in action. So we're going to do 3 x to the second y to the third all raised to the second. Now, remember, the 3 inside of the quantity, inside of the parentheses, that has an exponent of a 1. So, first thing I'm going to write is 3 to the second, because 1 times 2. Then x to the 2 times 2, which is 4. And y to the third times 2 is going to be y to the 6th. And then I kind of just look at this and say, okay, is there anything I can simplify? 9, x to the 4th, y to the 6th. Okay? And those are the positive integer exponent rules that we're aware of. Okay? The next thing I want us to go over are going to be the 0 and negative exponents. Now, there was a rule up above, all right? And it was that quotient rule. So let's go ahead, let's revisit that. Now, the quotient rule just says this. It says as long as the bases are the same, you can go ahead and you can subtract these exponents. But then the problem becomes, what if by subtracting, let's say, for example, x to the third divided by x to the 5th, when you subtract these, notice that you get x to the negative 2. What do you do with that? Well, it all goes back to the fundamentals, okay? That x to the third is really x times x times x in our numerator. X to the 5th, well, that's really x times x times x times x times x. All right, 5x is down below. And we know from simplifying fractions that as long as the numerator and denominator are the same, and according to our rule, a is not allowed to equal 0, which means our x's are also not allowed to equal 0, you can go ahead and you can reduce this and watch what happens. I'm going to zoom in for us. When I go ahead and reduce, they reduce, those x's reduce, and finally those x's reduce, and we know x over x is going to be 1, so you're left over with a 1 in the numerator, and you can see we have 2 x's in our denominator. Oops, wrong color. So this turns out to be 1 over x to the second. Therefore, up above, meaning right here, we can rewrite x to the negative 2 as 1 over x squared. And that's going to be our next rule, which is going to be the negative exponent rule. And all this says is that if you have a negative exponent, you can rewrite it by writing the reciprocal, and by flipping it or by reciprocating it, the sign on the exponent changes. All right, so technically, that is really a to the negative m over 1. So as you can see, if we reciprocate that, then we get 1 over a to the positive m. So real fast, something like an example, like 4 to the negative 3. Well, first, that's really 1 over 4 to the positive 3. There's our negative exponent rule, which is 1 over 64. So negative exponents allow us to write fractions. It's really what it does. Now, going back to that quotient rule, what if we have an example like this? What if we have 10 to the 15th divided by 10 to the 15th? Well, according to our quotient rule, bases are the same. So we subtract. We end up getting 10 to the 0. Now, I'm going to tell you that this is equal to 1. But I want us to understand why. All right, and I have a really easy demonstration here. Remember, if we did the quotient rule on, and I'm going to use smaller numbers because it's easier for us to wrap our head around. Let's say I did 5 to the third over 5 to the first. Well, old school, you could write it out, and then you would notice that this is equal to 25. All right? Or if we apply our quotient rule, we get 5 to the second, which is 25. So you still get the same answer no matter which way you want to interpret this. All right? But now, what if I took 5 to the second over 5 to the first? Well, that's going to be 5 to the 2 minus 1, which is 5 to the first, which is equal to 5. Finally, if you follow the pattern, the first example I did 5 to the third. Second example I did 5 to the second. But now I'm just going to do 5 over 5. Well, you and I both know that if the numerator and denominator is the same, it reduces to a 1. And this is why 5 to the 0 equals 1, or, and here's our big rule, the 0 exponent rule says a to the 0 equals 1, provided a does not equal 0. So basically anything raised to the 0 power equals 1, except 0 to the 0. All right, so there are our examples right there of all of our exponent rules. So now how do we do math with them? All right, and that's going to be the third topic of the day, which is our order of operations. Now, we did review the order of operations previously, so I'm not going to really dive too far down into that. But what I do want us to do is just to understand this one fundamental difference, all right? And that deals with a problem that looks like this. Here we have two completely different problems. Although they look similar, they are actually completely different. Now, if you want, go ahead and take a second, write down what you think the answers are, and then unpause the video or something like that, and compare what you got. So what I'm going to write are the answers now. For the first, this is negative 25. And then for the second example, this is going to be positive 25. And here is why. In the first example, negative 5 to the second, we can actually view this as negative 1 times 5 to the second. And according to the order of operations, you do anything in parentheses first, and then you do the exponents second. Then you do multiplication or division from left to right in the order that you see them. And then you do addition or subtraction from left to right in the order that you see them. So I have to evaluate this first. So that is going to be negative 1 times 25. And then negative 1 times 25 is negative 25. Now, how does this differ from the problem on the left? Or I'm sorry, on the right? I guess I need to learn my directions. The problem on the right is the quantity of negative 5 to the second. So this is interpreted as the quantity of negative 5 times the quantity of negative 5. So a negative times a negative is a positive, and 5 times 5 is 25. So that's the biggie. That's the one I really, really, really want you to understand. Okay? So the fourth topic out of this section is going to be evaluating algebraic expressions. Now, anytime you see the word evaluate, you should be thinking substitute. That's it. And I'm going to show you how to do this two ways. I'm going to show you how to do it by hand, and then I'm going to show you a nice little trick. It's not even a trick, it's a tool. A nice little tool that you can use. All right? So I'm going to take this problem directly out of your book. So So this is a wire made of a special alloy has a length of L equals A plus 0.0115 t to the third, where L is in millimeters, T is measured in degrees Celsius, to find the length wire, or the wire length, to find the wire length for A equals 8.380 meters, and T is going to equal negative 2.87 degrees Celsius. All right. So what they're asking us to do here is they're just asking us to evaluate this. They're telling me what A is. They're telling me what T is. All they want to know is what's the length. So the best thing that you can do is anytime you evaluate something, you want to write down the formula first. So I'm just going to write it down here. And then directly underneath, wherever you're going to make your substitutions, please put parentheses first. Then make your substitution. A is 8.380. T is negative 2.87. Now, the hardest part about this is using your calculator, okay? So if we were to do this using our calculator, I'm going to show you how to do this with a nice little technique that you can use. All right? So let's go ahead. Let's get out our calculator here. All right, there we go. So if you write it, you can type it in properly. And that's what I meant by using the parentheses is just so important. So we're going to type it in from left to right. 8.380 plus 0.0115. Wait, is that correct? Yep. Just making sure, sorry. Parenthesis, negative 2.87, end the parenthesis, and then raise it to the third. So our wire length is going to be 8.108. So let's go ahead. We're going to copy and paste this into our notes. We'll just use this screen right here. All right. Now we're cooking with fire. Oops. So right there's our answer. The 8.108. Okay? Now, the last topic unit conversions. This is by far one of the most difficult things that students encounter. And I think it's because we don't like fractions. So I'm going to show you a nice, easy way that we can convert something. All right. Now, in your textbook, in section 1.4, there is a table of conversion factors. Okay. So I'm going to go ahead and get them for us, but you're going to have to bear with me real fast because I have to sign in to my math lab and all that good stuff. So we're going to go ahead and we're going to do that. So like I said, please bear with me. I'll just talk to you here. That way I can get the conversions. All right, so like I said, in section 1.4, all the way down here, we're going to get to our conversions. And here they are right here. So it's table 1.1. All right, and here's how these conversions work, okay? Because I know a lot of us, we read this like for example, in the very first row, okay? 1 inch is equal to 2.54 centimeters exact, all right? But the thing that I don't think sometimes we do a good job at explaining is that that is a ratio, all right? In other words, I can write that conversion factor as 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. So that's how this whole table works. So if you understand that, well, then a problem like this convert 17.8 inches to centimeters is very simple, okay? And let me demonstrate how simple this really is. This unit right here, this measurement, the 17.8 inches is what I gave you. It's like if I asked you to measure something, this is what you told me. So what I know is that is 17.8 inches over 1. Because you can make any number you want a fraction by putting it over 1. Now, if I want to convert to centimeters, I'm going to multiply by a conversion. That's what I'm going to do. Okay? The question becomes, what is my conversion? Well, if you look up above, I'm going to highlight them in this nice green color. We have two conversions. We have inches over centimeters or centimeters over inches. And all you have to do is remember, how do fractions work? Well, if you want to simplify something, the numerator and denominator has to be the same. Remember, numerator and denominator will reduce to 1. So if you think about it in terms of just straight math, here's what we have. We have 17.8 inches. We're going to multiply this by our conversion factor so that the inches reduce. And in order for the inches to reduce, I already have them in a numerator, which means in my next multiplication, the inches, they have to go in my denominator. This way, when I carry out my multiplication, I have inches in the numerator, inches in the denominator, therefore, they reduce. All right? So what goes in my numerator is my conversion. It's the units that I want. In this case, it's going to be centimeters. So if you look above, and let me get rid of these things. So if you look above, and I'm going to zoom out, the unit conversion that we want is this one. So we know there are 2.54 centimeters per 1 inch. And now, when I go to do my multiplication across the top and across the bottom, my inches reduce. My answer will be left in centimeters. All I got to do is just multiply. So 17.8 times 2.54 is 45.2 centimeters. All right? And that is how we convert things. It does not matter what the conversions are. This is how you set it up. So let's do another one here. Let's do another example, all right? Let's convert 15,381 feet to miles. Okay? Well, the first thing we need is our conversion table. That's right here. You are going to scan this from left to right. First, feet and miles. Those are lengths. So we're going to be looking underneath the length column. These are columns. All right. Now, do we know how many feet are in a mile? Of course, it's right here. 1 mile equals 5,280 feet. So watch how I set this up. I'm going to write down what I was given first. I'm going to multiply this by my conversion factor. Now, in this case, since I'm given feet, I need to reduce the feet. So the feet go down in my denominator. Miles comes up top. And now I just put the numbers in. So I look at my conversion factor. 1 mile. 1 mile, 5,280 feet. When I do my math, the feet, they will reduce because you have one in the numerator and one in the denominator. So all I have to do is take 15,381 and divide it by 5,280 to give me 2.91 miles, or just 2.9 miles. And that's how you do this. Even if you get something that is maybe requires multiple steps, okay? So let's say convert 42,119 meters to miles. All right. Once again, we know this is a length, and I'm sticking with lengths just to show you how the process works. All right. So we're sticking with lengths. And when I look above, I have 1 mile equals 5,280 feet. All right. That's one conversion. I also have 1 foot equals 0.3048 meters exactly. So it looks like in this scenario, what I'm going to have to do is go from meters into feet and then feet into miles. And here's how we do this. Remember, I'm going to get our conversion factor table up here again. So we're going to start off by writing what we know. We know we have 42,119 meters. Next, we need to go into feet. So the meters have to reduce, so they're going to go in my denominator. Feet must go in a numerator then. All right? If you want to, you can go ahead and substitute the numbers in. That's fine with me. So 1 foot, 0.3048 meters. Now, please be aware that if you did this calculation right now, the way it looks, the meters reduce. Okay, the meters reduce. Your answer is left in feet. But we don't want feet. Therefore, we need one more conversion. And that conversion is going to take us from feet into miles. Since feet is in the numerator, I will put in my next conversion, I will put it in the denominator. And I will put miles up above. So, how many feet are in 1 mile? 1 mile, 5,280 feet. And notice, if you were to do this calculation from left to right, the meters reduce, the feet reduce, your answer will be left in miles. So, all I have to do, and I'll do this in the calculator so you can see how to do this. All right, so I'll move this over here. So we started off with 42,119 meters, and we're going to divide this by the product of 0.3048 times 5,280. So notice how I put the entire denominator in parentheses. I hit enter, and here's what we got, 26.2, which is the distance of a marathon. And that is how we do our unit conversions. Now, any one of these up above, length, volume, weight, mass, energy, they're all done the same exact way. Okay? The only thing you got to worry about is just setting up the units properly. Okay? So I hope this helps, and I will see you in the next video.